So I decided to expand the solution of problem 7 and including more details about cover R method. So as a result, I have to make the video once again. So let me just start from scratch. So number 7, the problem statement asks you to calculate the indefinite integral of 1 over 1 minus t squared. So this is a standard partial fraction problem. So all you need to do is first you factorize the denominator, and the denominator is factorized as 1 minus t, 1 plus t. So then, yeah, because all these factors are linear, so we can set up if we set up the partial fraction decomposition of this guy, so what we have is a over the linear factor and plus b over the linear factor. All the powers being 1, so that means you don't need to worry about any other things. So this will be the setup for the partial fraction. And then you will be able to solve either using the traditional way or use the cover R method. So no matter what, you will come up with a equals 1/2 and b equals 1/2. So then plug it back, so you can see that 1 over 1 minus t squared equals to 1/2 times integral 1 over 1 minus t plus 1/2 times integral 1 over 1 plus t. So these two fractions are very easy to integrate. So you are basically getting natural log functions. Be careful about the sign in front. And then using the logarithmic laws, you will be able to simplify the conclusion as this. Okay, so now let me just explain how did we carry out the calculation of a and b. So there are multiple ways for us to do it. So the standard procedure of partial fraction decomposition is to calculate the right-hand side and compare the coefficients. So here are the details. So first of all, I started by setting 1 over 1 minus t 1 plus t to be a over 1 minus t plus b over 1 plus t. Now, let me calculate the right-hand side. So the common denominator is obviously this guy. So combining these fractions all together, you will see that what we have is 1 minus t 1 plus t as the denominator. And the numerator will simply be a times 1 plus t. So because to make the common denominator, I need a 1 plus t factor on top and the bottom. So similarly for the second one, I need a 1 minus t on top and bottom. So then simplifying the numerator, so the constant terms are going to be a plus b, and the t terms will be at minus bt. So that's how I get to this part. Then we understand the left-hand side to be 1 plus t 0. We may compare the coefficients, namely, because left-hand side has to equals to right-hand side, so the numerator should be the same, and numerator is precisely 1 plus 0t, so 1 plus 0t must be equals to a plus b plus a minus bt. Okay, so then constant terms should match up with constant terms. That's how we get the first equation. Coefficient of t should match with coefficient of t, so that way we get second equation. Solving this equation, we get a equals to b, and then the second one tells me a equals to b, and plug in the first one, we get a equals to b equals to 1/2. So that's it. So this standard procedure is very easy to understand, but generally speaking, this is not very convenient. So this standard procedure applies to all possible cases of partial fractions. So basically, no matter how complicated the partial fraction is, once you set up the decomposition, you can always use this method to handle the partial fractions. But despite this generality, so it's not very convenient. So in particular, in calculation, it can be very complicated if the denominator gets worse. So below is a much more convenient method that can handle multiple linear factors and one quadratic factor. Okay, so I mean, understanding this particular case would most likely be enough for this class. Although I would at least include one example where you will have to use the general procedure to handle, namely the standard procedure to handle the partial fractions. But this will not appear until very late. Okay, so but let me just start with the cover R method. Let's first apply the cover R method to this partial fraction first. So first of all, this method is very convenient in handling linear factors. So the idea is quite simple. So starting from this identity, we first start by multiply both sides by 1 minus t. So after you multiply both sides by 1 minus t, then this guy is gone. This 1 minus t is gone. And over here, you get the 1 minus t factor in this location. So as a result, I can rewrite so after the multiplication, I'm getting at something like this. Here, I intentionally let a space over here so as to understand, the understanding for this is I'm just covering up the factor 1 minus t. Okay, so after this multiplication, we get to this identity. And if we evaluate t equals to 1, then the point is, if you look at the right-hand side, so if you evaluate t equals to 1, then this whole thing becomes 0. So only A stays on the right-hand side. So in other words, by evaluating t equals to 1, you will be able to get A equals to, so the left-hand side evaluated at t equals to 1, and you can directly see that this is 1/2. So you could understand this expression as, this method as, if we covered the denominator of A in the left-hand side and evaluate t as the number making the denominator of A vanish, we obtain A. So basically speaking, we first covered 1 minus t on the left-hand side, and then we find that, okay, so t equals to 1 makes this covered factor to be 0. So that way, I will just evaluate t equals 1, and my claim is this is giving me A. So this is how I obtain A by one simple calculation. There is no comparison. There is no system of equations. This is just one step to obtain A. Okay, so to obtain B, so same story. We cover 1 plus t, the denominator of 1 plus t. And then we evaluate at t equals to -1 because t equals -1 makes 1 plus t 0. Okay, so that way I will be able to get that my B is simply going to be 1 over 1 minus t with 1 plus t covered, but then we evaluate t equals -1. So the answer will be 1/2. All right, so this is the cover-up method applied to the simple linear factors. So namely, there are no powers in these locations. So what happens if there's powers? So in this case, yeah, if there are powers of linear factors, then this method only gives the coefficient of the highest power. But it doesn't mean that we have to deal with the lower powers by usual way. For lower powers, we could also handle it by subtraction. Let me explain in greater detail in the next example. So let's start with the partial fraction decomposition of 2t plus 3 divided by t minus 1 squared times t plus 1. So first of all, the factorization involves a higher power. So the drill is you need to start from the highest power of this linear factor, and you need to go all the way down to the first power. So for example, if I have got t minus 1, in case I have t minus 1 to the 4th over here, correspondingly, I will need to set a over t minus 1 to the 4th plus b over t minus 1 to the 3rd plus c over t minus 1 squared, and then plus d over t minus 1. So if I have 4th power over here, then I need to go all the way down to degree 1. So now we only have 2nd power over here. So that's why we only need to include these two terms over here. So this is going to be the partial fraction decomposition corresponding to the primary factor t minus 1. Then another factor t plus 1, well, it's only one of 1st power. So then we only have c over t plus 1 over here. Okay, so this is the partial fraction decomposition we should set up for this guy. And now the cover-up method will basically yield the following. So you could cover up t minus 1 squared. So the effect is nothing but just when you multiply t minus 1 squared on both sides. And if you multiply t minus 1 on both sides, this guy is gone and this guy is gone. So then if you evaluate t equals to 1, what we are getting at is simply going to be these. Actually, so these two guys will basically vanish because once you evaluate t minus 1, t equals to 1. So then what remains on the left-hand side is going to be this guy evaluated at t equals to 1, and what remains on the right-hand side is simply a. So that's how we can tell that a is precisely 2t plus 3 divided by t plus 1 evaluated at t equals to 1, and the answer will be 5 over 2. So similarly, c is obtained by the same spirit. So you multiply both sides by t plus 1. That way you get something like this. Evaluating t equals -1, this whole thing vanishes. What remains is simply going to be this identity over here. All right, so this is what we mean. So the cover-up method gives out the coefficient of the highest power. So now that we can figure out A and C, because the highest power is square is got good, the highest power 1 is good, so that's what the cover-up method can immediately get. Okay, so now to decide B over here, what we could do is the following. To decide B, we can subtract A over t minus 1 squared on both sides. So in other words, originally it was this guy equals the sum of these three guys. Now I will just move I will just subtract both sides by the first term over here. So then left-hand side becomes this and right-hand side becomes this. Okay, so here is the important thing. If your A is calculated correctly, then if you simplify the left-hand side, the left-hand side can be simplified as a fraction with only t minus 1 in the denominator, but without t minus 1 squared. So if everything is calculated correctly, then you are not supposed to get t minus 1 squared over here. So now let's plug in a equals to 5 over 2 and see what happens. So that means left-hand side, this a is replaced by 5 over 2. And now, in order to actually handle the fractions, I need to find a common denominator. I need something like this. So the common denominator will be 2t minus 1 squared t plus 1. Then for the first factor, I need a 2 in the front. And for the second factor, I need a t plus 1 on top and the bottom. Okay, so that's how I get 4t plus 6, because that will precisely be multiplying out 2t plus 3. And 5t plus 1 is just obtained by here. Okay, so this will be my numerator after the simplification. And then you could further multiply everything out to get 4t minus 6 minus 5t minus 5. And 4 minus 5t gives me minus t, and 6 minus 5 gives me 1. So that way you get minus t plus 1. Okay, just keep in mind that minus a plus b divided by b minus a, so a minus b, so this is simply going to negative 1. So that's why this factor can be cancelled out with one copy of t minus 1 downstairs, so the result is minus 1. All right, so you see, if my a is correct, then after the simplification, I am going to only get t minus 1 downstairs, and there shouldn't be any t minus 1 squared. Then, okay, so therefore, well, the left-hand side is simplified to be this guy, and look at the right-hand side over here. You see that, all right. So B is now the highest power of the partial fraction decomposition of the left-hand side. Then you could use the cover-up method to decide that, okay, B equals to minus 1 over 2 with this t minus 1 erased, covered up, and moreover, evaluate t equals 1, and the answer will be minus 1/4. So that way, you could have 2t plus 3 divided by t minus 1 squared, t plus 1, to be decomposed as follows. Okay, so this will be the situation. This will be the cover method for powers of linear factors. So aside from the powers of linear factors, if there exists only one quadratic factor, so the cover method can also apply. The only issue is, the cover method does not immediately give the coefficients, but we may again apply subtraction. So let me just explain further details about how we apply the subtraction in this case. So let's just attempt the example. 3x squared minus 2x minus 1 divided by x minus 2 squared, x squared plus 4. So remember, when there is so first of all, for the linear factor of x minus 1 squared, so because it's the second power, we need to start from the highest power and go all the way down to 1. For the quadratic factor, namely x squared plus 4 over here, so what you should do is, downstairs you have x squared plus 4, and upstairs you have cx plus d. So make no mistake, you should have a degree 1 polynomial on top. So it's not going to be c over x squared plus 4 that easy. That won't be the case. For quadratic factors, it's always going to be cx plus d. It should be a degree 1 polynomial instead of a constant. Okay, so then as what we previously did, so these two guys are the same. At the very least, we can determine a by cover-up method. So we cover out x minus 2 squared and evaluate the x equals to 2. So that way you get you get an expression of a. So then calculate it out, you just get 7 over 8. So let me just skip the arithmetic over here. You could perfectly do it by yourself. Then once you obtain the a over here, so then by the subtraction process, so you will be able to determine the b over here. So this is the detail of the subtraction. So I subtracted this guy with a over x minus 2 squared. So this is what I did. And after the simplification of the fractions, I'm getting at something like this. Okay, so this is actually like, this looks very complicated. So, and also we still have x minus 2 squared. But remember, if we carry out all the calculations correctly, so over here, x minus 2 squared is not supposed to appear. So this basically tells me that, okay, so in the numerator, there should be an x minus 2 factor. Then you could use the trial and error method. So you see that originally I have got x squared is going to be 17. And so the coefficient of x squared is 17 and the constant is minus 36. So, but I know that I'm supposed to have x minus 1 as a factor. So in the trial and error, I am supposed to have 1 and minus 2 as one of factor. But then 17 divided by 1, that would be just be 17. And minus 36 be divided by 2, I will just get divided by minus 2, I am getting at positive 18. So this way, yeah. And if you calculate the crisscross sum, you get 18 minus 34. And 18 minus 34 is precisely minus 16. So yes, so this way it works. So that's how we obtain the factorization, simply by trial and error, because we already know we are expecting that x minus 2. So that's why actually we could carry out the factorization really easily without really many trials. Okay, so once we factorize the numerator in this way, then what we are getting at is, well, these two guys altogether should be equals to this whole thing, namely this guy over here. Okay, so then you will be able to read B from the cover R method. So again, you cover R x minus 2 and evaluate that x equals to 2. So this is your B, and I'll leave it to you to handle the arithmetic. So you are, at the end of the day, you get 13 over 2. Okay, so this way we obtain the A, we obtain the B, and now what remains is Cx plus D. And in order to handle that, well, subtract again. So all you need to do is, okay, so we started from, let me see. We started from this guy over here, and if I subtract B over x minus 2 on both sides, then the point is, yeah, on the left-hand side, after the simplification, so I am supposed to get rid of x minus 2 factor, and what remains is supposed to be a fraction with only x squared plus 4 downstairs. Let's carry out that process. So if we plug in B equals to 13 over 2, and we subtract the left-hand side by the whole thing, so this is actually the expression we get. And finding the common denominator will be 2, x squared, x minus 2, x squared plus 4. So that means I need a 2 on here, and I need the x squared plus 4 in here. So this is how I obtain this expression. So combining so simplifying the numerators, I get 34x minus plus 36 minus 13x squared minus 13. So I will keep the minus 13 here. I will keep the 34x over here. So 36 minus, okay, I made a mistake over here. This is 13 times 4 is supposed to be minus 52. So 36 subtracted by 52, I am supposed to get minus 16. Okay. Again, since we are, so originally we are, so we could again do the trial and error, knowing that we are expecting the x minus 2 factor. So you know that x1 minus 2 must appear. And minus 13 divided by 1, that would be minus 13. And minus 16 divided by minus 2, I get positive 8. So if you do the crisscross sum, 8 plus 26. So that way I'm getting at 34. So everything works. So that's how I'm getting at, okay, I think over here I am supposed to get x minus 2 and 13x. It should be minus actually. All right, so over here there's a typo. Let me just correct it afterwards. So this is supposed to be minus over here. So then what we could do is now simplification. So we're simplifying the whole thing of what we get is supposed to get minus 13x plus 8. So this guy is supposed to be equals to Cx plus D. So as a result, I guess C equals to 13 over 2. So this part is fine. But D over here, it should be positive 8 over 2. It should be positive 4. Okay, so I think this is the typo I have introduced when I was writing this set of notes. Okay, so as a result, we could directly say, okay, so my partial fraction decomposition will be previous A, previous B, and plus together with C and D. And notice essentially what I'm not doing anything else. I am simply writing, you could simply write this guy directly over here because they are supposed to be the same. Okay, so I think this is how we handle multiple linear factors together with one quadratic factor. So in this course, we will only handle simple quadratic factors. So we do not worry about powers of quadratic factors or products of too many quadratic factors. Although sometimes I think later part of this class, I will also require a product of 2 quadratic factors, but that's it. 2 different quadratic factors. So the reason is that once you learn complex numbers, quadratic factors may be transformed into linear factors. So for example, x squared plus 4, you may actually regard it as the product of x plus 2i, x minus 2i. Then you could use the cover R method for linear factors to handle the corresponding partial fraction decomposition, except, yeah, the coefficients are now supposed to be complex. So knowing complex numbers, you can transform everything into linear factors, and cover-up method applies to everything. So, but I understand that many students in this class did not have enough experience about complex numbers. So this is why I will not require this part in class. And if you are comfortable with the cover-up method, as I mentioned above, so that will be perfect for you to succeed in the later part of class. Okay, so for the further practice, you should actually try to find the partial fraction decomposition of these guys. So for the first guy, it's basically, yeah, you use the trial and error. You could actually factorize the denominator as x minus 5 and x plus 3. So then this will be like a simple cover-up method as we see in the quiz problem. This one will be factorized as x times x minus 1 squared. So you need to handle 1 power over here. And finally, over this guy over here, so this will be 1x times x squared plus x plus 7. So this x squared plus x plus 7 is a quadratic factor, irreducible quadratic factor. So, but we only have simple linear factors. So this one should be slightly easier than what we have done over here. Although the calculation might not, the arithmetic might be complicated, but it's not going to be as difficult. Okay, so I think that's all I want to say about problem 7.